All right, welcome back everyone. We have 7.3 logarithmic properties. Now you have two learning goals, or you have one learning goal to use property of logs to simplify expressions. And sorry, I was going to put two before, but simplify. We are going to do two things. We are going to expand and we are going to contract logarithms. Now, what are your properties of logarithms? Okay, there's a lot of them. Here's the first three. Okay, and if you notice, each one of these has a matching property for exponential functions, okay, or just for exponentials, all right? Now, if you look here, we're going to say that the product property for logarithms is that when you have a log to a base number and you're multiplying two, so that's linked right here, that we can split this into addition, okay? Notice how x was split here and y was split here. Okay, so this is very similar to the product property for exponentials, right? When exponentials, if we have b to the power of x times b to the power of y, we get b to the power of x plus y. This is a very, very similar property here. Notice multiplication split to addition, okay? Now the next one is saying that if we have log to a base number and we're going to be dividing, that we split to subtraction, just like we would have with exponentials, right? And then finally, the last one here, if we have log to, base number to x to the power of y, we can take this number y and bring it to the front, as you see here, okay? And that one's a little bit different, all right? Now, if you can go this way with the property, that also means that once you're here, you can go this way. So we do plan to do both. We plan to go this way and expand. And then we plan to go from here, which would be, simplify or contract. Okay? Because all properties work both ways. All right? Now, those are the first three properties. The next one here, you have definitions of logarithms. These are properties. Okay? They just are a little, how do I say this? It's kind of more like we're just using the way that logarithms work, right? So if you think of the circle method, if we have this base to the power of 1, right, the answer is this, right? Like that's how you would write it. So you would say b to the power of 1 is equal to b. And so that makes sense that your answer would just be 1 because it's the same thing, right? And the power has to be 1, okay? Let me try that explanation again here, all right? When you see the base number and the number you're taking log of the same number, you have to be taking this to the power of 1 to get that, all right? Or else how is it the same number? So if I have log 3 of 3, well, the answer has to be 1 because 3 to the power of 1 is 3 if we think of it in exponential form, okay? The next one is log b of b to the power of m equals m. All right. Now with this one, it's very, very similar, but we're sitting here saying that, if I wrote this in exponential form, so b to the power of m is equal to b to the power of m, it makes sense that these numbers have to be the same, right? Or, because these are the same, so they have to be taken to the same power to be equal, especially since they have the same, variable, right? So if we see this, the answer is whatever the power is. So if I had log 3 of 3 to the power of 2, the answer has to be just 2, okay? Because 3 to the power 2 gives you 3 to the power 2. And then finally, we have log base b of 1 is equal to 0. And that makes sense. How do, what do we take b to the power of to get to 1? It has to be 0, okay? Now, the last thing right here, this is the last definition. This is really going to be more important when we get to solving exponential equations, which is the next lesson, the next two lessons. When you take a base number to the power of a logarithm and these base numbers are the same, then your answer is just k. And we're going to use this property to take each sides of the equation to the power of a log in order to cancel out exponential equations, all right? And so this I'm just kind of floating your way that we're going to need this pretty soon, okay? But we won't be really doing this one in the lesson. Okay. All right, so here we're going to expand the logarithm expressions, and we're going to do that. I'm going to do it, and then you're going to do it, and then we'll get to contracting them. And the reason why we're taking this approach is it's much easier to contract logarithms once you've seen them expanded. It's a little bit easier to see the connection. Okay, so here we have log base 4, and we have 5 times 10, and these are together because it's multiplication, so they're not separated. All right. When we see that, we can take this and we can really write it as log 4 of 5 plus log 4 of 10. And this is considered the same thing. Okay. Now in this one, you might be going, well, we went the opposite way of simplifying, right? Don't we always want to be in the most simple form? And yes, but sometimes this will help you unlock another step. And it's going to be more helpful for when we do want to go from this back to this. Okay. Okay, so here on the right side we have log base 6 of 5x to the power 4. Okay. And when you have log base 6 5x to the power 4, you have multiple properties going on here, right? You can look and you can see, well, I have a 5 times an x to the power 4, and so that maybe that could split. And you can say, well, I have a power here, so that's power property, and that probably needs to go in the front. However, notice how this 4 is only being applied to the x, okay? That power property, let's go back a little bit here. That power property means that this power is being taken to all of that number, okay, whatever is in place of x, all right? Not just one of them. So we need to split them first using the product property, and then we can apply the power property. So let's use the product property first. I'm going to split this into log base 6 of 5 plus log base 6 of x to the power of 4. Okay? And again, when we do this, we need to be able to bring it back to the original problem. Okay? If I had done the 4 first, then there would be a 4 in front here, and if I bring that 4 back into 5 to the power 4, that's just not true. Okay? So now we can use the power property here. So that's what we're going to do. We're going to use the power property. And we get log base 6 of 5 plus log base 6, 4 times log base 6 of x, because we moved the 4 in front. And now this is the most simple form that you can have. Okay? All right, let's go to 2 for you guys to do. Now this one brings in the quotient. The one on the right, obviously a little bit more difficult, but I really am doubling down on wanting you to try something kind of like I've showed you, but not exactly like I've shown you, because that's where you really learn, right? So why don't you guys give these 2 a try, and then pause it, and then I'll go over it. Okay, so we have log base 7 to the power of x squared over divided by y to the power 3. That should trigger quotient to you. And so we could split this to log base 7 of x to the power 2 minus log base 7 of y to the power of 3. All we did was split that up, okay? Now the one on the right, you could see we have an a squared and we have a b divided by c, okay? You cannot touch this yet, all right? Because it's all in parentheses, it's being multiplied with this. You first need to split them and then deal with them separately, okay? So I'm first going to use the power product, okay? And I'm going to separate these, sorry, not the power, the product property. And I'm going to separate this into log 2 of a squared plus log 2 of b divided by c. And now over here, I can do the power, and over here, I could do the quotient. And so this becomes 2 log 2 of a plus log 2 of b minus log 2 of c, like that. Okay? So, sometimes you gotta, the orders can be a little bit tough, but I would focus on splitting and then dealing with each one separately. Okay, now you've seen the expansions, and now these are ones that are already expanded, and I think it'll be a little bit easier to bring them back together. So when you're bringing them back together, though, you have to be careful of the base number, because when you expanded, obviously they had the same base number because you went from here out, right? And so, of course, they had the same base. But now we need to make sure that these are the same. These products or properties only work when they are the log with the same exact base number, okay? So we have this, right? We see same base, we're adding. That should tell you product property, so we're gonna go the other way. This becomes log base 3 of 2 times 6. And those 2 and 6 are together, right? And so now that we have that, well, that really means that this is log base 3 of 12, and that would be your answer, okay? And this is very important to notice here. This would be very helpful for future math classes. Sometimes we want to take numbers and rewrite them differently to get another step. 12, right? If we wanted to go in the reverse, okay, we can split 12 to be 2 and 6, so that then we can use the product property to expand it. Or I could split 12 into 4 and 3 and expand it that way, okay? That might help me. Maybe there's another log, you know, that is, you know, similar, and then I can now simplify, but choosing the right numbers for that, you know, comes up to the problem at hand, okay? Now the one on the right, we have log 80 minus 2 log 10. Remember, that must be the common log, okay, because this must be the common log because it didn't say it, so it's base 10, so they do have the same base number. Now we can see here that, you know, this one has a number in front, right? So just like here, we split first and then dealt with them separately. Now we need to deal with them separately and then bring them back together, okay? So I'm going to put this 2 up top, and you know, that minus is going to stay there, okay? So this becomes log 80 minus log of 10 to the power of 2, okay? Now we can see that there's the quotient power. This becomes, or quotient property, this becomes log 80 divided by 10 squared. Well, 10 squared can actually be simplified, right? Or you know, multiplied to get log 80 over 100, and that can actually be simplified to log 4 over 5, okay? Notice how we couldn't do any of this simplifying when they were in their original forms. Log 80 had no way of being simplified. You know, 2 log 10 had no way of being simplified until we applied the quotient property and brought them back together. Okay. Now, here's the next one, all right? These two are for you to do, so why don't you guys pause it and give them a try. I know they're a little bit different, but, you know, I want to see if you can apply what you've been learning to these problems before I show you them. So pause it, and then I'll go over it. All right, so hopefully you were able to get these, right? You need to deal with them separately and then bring it together. So we're going to do our power rule, power property twice, and we get log 4 of x to the power of 5 plus log 4 of y to the power of 3. Now we see, verify, same base number. We're good there. So let's bring these back together. Log of x to the power of 5 times y to the power of 3. Okay, because we see that we're adding logs with the same base, so we can bring them back together and multiply, and then this is the most simple form. I don't know about you, this looks better to me than that, right? Now over here on the right, we need to simplify what's in here first. Okay, so log 10 plus log 3. Okay, let's go ahead and simplify that. So these are a common log again, so we're going to have to handle the parentheses. We're using that product property. So this really becomes log 10 times 3 in the parentheses, or really just log 30. Okay, now we need to handle the other one before we can bring these back together, right? That 2 needs to go back into being a power, so we get log 30 minus log of 5 to the power of 2, which then this becomes quotient of powers, and so that we have, you know, log 30 divided by 25, which I'm going to expand that 5 squared, or really just log 6 over 5. Now look at the importance of this. Log 6 over 5 is the same thing as log 10 plus log 3, and then all of that being subtracted by 2 log 5. If I can simplify that, I'm doing that, okay? Okay, so we have find the value, right? And this is going to really bring us back to those definitions that we had at the very beginning, okay? If you notice, right, we have, the same numbers here. We have the same base number, and we're taking the log of the same number as being to the power of 4. If you go back to your properties, that is one of them, okay? Think about this. You could do this with the circle method. You could sit here and go, 3 to the power of x is equal to 3 to the power of 4, which means that x has to be 4. Or you can remember your rule and know that when you have the same base and the log number you're taking of, those just disappear and your answer is whatever that power was, okay? Now we look at the other one. We have 4 log base 6 of 6 to the power of 1/3. A little bit tougher, okay? And you may be wondering, well, do I bring this back in first, or do I deal with this and then bring this back in? And the answer is either. Let's do them both ways. So I'm going to go over here, and I'm going to do this one where we deal with the 4 second, okay? And then over here, I'll do it again where we deal with the 4 first, okay? So here, same base number, which means the answer is really just 1/3. So this becomes 4 times 1/3, or just 4/3. Now here, I'm going to bring this back in first, and we get log base 6 of 6 to the power of 4/3, which again, you still have the same number here, so your answer is just 4/3. Didn't matter there, okay? Now, if you're going, okay, that's great that worked for this problem, right? What happens if I'm struggling later and I need to, figure it out? Well, the answer to that is, try them both ways. If you get the same number, either way will work. If you get different numbers, think back, okay, well, which one gives me a number that's more realistic, okay? Now, here's 2 for you guys to do. All right, why don't you guys pause it and give it a try. Okay, so we have log base 2 to 14 minus log base 2 of 7. This should hopefully trigger quotient of powers. We verify we have the same base, so we can bring this back together as log 2 of 14 divided by 7. 14 divided by 7 really is 2. And so then I have the same numbers here, so it's whatever the power was, which that means there's imaginary 1 there, so my answer is just 1. Look at that. This whole thing is really just 1. Now log base 5 of 125 kind of brings us back, not really a definition here, but 5 to the power of x must give us 125. And that we just have to think about. 5 times 5 is 25, times 5 again is 125, so x is equal to 3, okay? Now, that is actually it, and this might be one of the shorter videos, so, yippee, right? But I want to just talk to you a little bit about why this is so important. Obviously, we can sit there and say that, contracting logarithms makes them more simple, and that's why you should learn it. But what's the bigger picture? We know that logarithms are inverses of exponentials. Got it. But what's the bigger picture? The bigger picture is calculus. Calculus is where you get to this point where math actually becomes advanced and cutting edge and applied in the workforce beyond just, what computers do for us with algebra. When I took Calculus 1, I noticed that the students who were successful in Calculus 1 were students who were good at algebra and trig. And obviously logarithms fall under algebra. If you are good at manipulating equations to make them more convenient, and you know your trig, Calculus 1 will be very easy because all you're going to have to do is focus on simple calculus steps, because that's all you do in Calculus 1. You use simple calculus steps and then a ton of algebra and trig, okay? So, I don't always like my reason to be that this can be helpful for future math, but this is really that case. If you really want to take it to high-level maths, you're looking at engineering, you're looking at computer science or science STEM major, you're going to need Calculus 1. There's no way around that. And if you want to be successful in Calculus 1, you need to be good at algebra, you need to be good at trig, and logarithms will definitely 100,000 gajillion% be used for very difficult calculus differentiation problems, okay? No way around it. So get good at them now so that your future self can thank you and your future self's life is easier, all right? All right, everyone, that's it. I'll see you guys next time. You know the deal, like and subscribe.